So next up, we have Reynold Harbin, who's the Director of Product Marketing at DigitalOcean. Reynold works very closely with our product team to bring all of the products and features that we release. And he will be moderating a panel around scale up or scale out. Reynold has a background in software development, systems administration and operations, and product marketing of cloud infrastructure services. So please welcome Reynold.
Thank you. Okay. Is this mic on? Hello? Hello? Is this on? All right. Great. Thanks. Thanks very much. I am excited to talk to you about scale up and scale out. One of my favorite subjects is scaling, and I want to introduce three folks for the panel. Panelist one is Anshul Pandey, co-founder and CTO of Accern. Accern is a data design startup that provides predictive news analytics solutions to companies to assist with intelligent data-driven decisions. Accern is based here in New York City. Please welcome Anshul. Secondly, we have Yvan De Boeck, VP of Engineering at Bevi. Bevi is a hardware and software company. Bevi is one of the fastest growing beverage companies in the world, founded to eliminate plastic bottles. Bevi is based in Boston, Massachusetts. Welcome. Thanks. And finally, Russell Bierschbach, Managing Partner and CTO of RouteTrust. RouteTrust's core product is a cloud-based platform as a service that's capable of handling tens of thousands of phone calls per second while being managed by a simple, easy-to-use web-based interface. RouteTrust is based in Austin, Texas. Please welcome Russell. Thanks. Okay. I'm going old school here with some notes here. So we're going to go through just introduction and some application details from all the panelists. Several questions. I'm going to actually hopefully challenge the team here a little bit to also think back about the first cloud server you ever spun up and what it was used for, but work it into some of your answers over the next 20 minutes. So you don't have to do, not right now, but maybe as you're answering these things. So I thought maybe I'd start with you, Yvan. Maybe you can tell me, tell us about your business and the customer-facing applications that support it.
We make a hardware product. It's an internet-connected water cooler, a smart water cooler that can deliver unlimited still, sparkling, and flavored drinks. And we were founded in 2013, and now we got over 2,000 machines all over the US and Canada.
Okay.
The software team is very small, only 3 people, and that includes me as a developer.
Okay, and these are connected to the internet then?
Yes.
What are the applications for that?
And so our operations, they rely very heavily on the back end, where we compute the amount of consumables that are still left in the machines. And in the beginning, we learned a ton about how the hardware actually functioned in the real world, because we're connected to the water system. So that's different in New York versus Boston. So we learned that through our backend services. And we run on DigitalOcean since the beginning. So we never we never owned the server and don't really plan on owning one. So right from the beginning, we use DigitalOcean to deploy our apps.
Mm-hmm. Okay, great. Russell, can you tell us a little bit about your business and the customer-facing applications that support it?
So yeah, RouteTrust is a wholesale telecommunication service provider. Our actual interface to our customers is the phone everybody has. Our website has several thousand users, but it's a minority of our traffic. We get, as I said, several thousand users logging in a day, but we handle up to 100 million phone calls a day. And so our scaling challenge is every call that comes in, looking those up, billing it, rating it, routing it. So our customer-facing application is the phone.
Mm-hmm. Anshul, can you give us a bit of background on your business and the customer-facing apps?
Sure. So Accern is a real-time news analytics application. We crunch hundreds of millions of articles as they come in almost every day. And yeah, we provide basically a very low latency predictive analytics feed to investment banks, hedge funds, people who have a very high requirement of low latency feeds, and that means we have a very, very large requirement of high compute resources. We run a lot of machine learning models, and yeah, that's our core offering.
Okay, that's great. Can you tell us a bit about, just to get into the details about the application itself? I guess first and foremost, how do you think about application capacity?
Right. So, I mean, so if you look at Accern as a whole, the kind of problems that we are initially tackling is it's a very classic intersection of big data and machine learning modeling, right? And both in themselves are very, very big monsters. So for us, the capacity of an application is whether it's generating, it's cutting edge in the sense of whether you're utilizing the most sophisticated machine learning algorithms, and whether the algorithms are generating the predictions in super low latency format, so that by the time the article comes, it just basically gets out with a lot of quantification. So right now, our application is around 40 milliseconds latency from the time we get the article to the time we churn out the predictions and give it out. And yeah, that's what we are trying to optimize going further as well.
Mm-hmm. Okay. So on the theme of just more application details itself, Russell, perhaps you can give the audience a view of how is your application architected, and can each component scale independently, or are they all kind of put together in one large application?
So the core part of our application is media proxying and sometimes transcoding, and we do that on DigitalOcean servers. We have some points that don't scale. Our customers connect to their customers and their vendors via static IP addresses, floating IPs, and so those are a constraint, but we work with our customers to plan that out. So if you're going to have more than 2,500 calls a second coming in, spread that out on multiple IP addresses, multiple gateways. And our largest customers are in that range, and so they run 5 or 6 different gateways across the world. Once the calls hit our signaling gateways, they get load balanced to different media servers, which is really where the bulk of our scaling occurs. We have to launch servers to handle the concurrent calls, and it depends on how much transcoding is going on, and just packet relay. And that's where the core application logic actually runs in terms of looking up the customers, doing the rating, doing the billing, producing that billable record that ultimately we have to invoice. So our primary scale is adding media servers as calls ramp up or down. We actually run a pretty steady base. We don't scale real time. We have upscaling to handle unexpected spikes, but we really run at a base level because our traffic pattern doesn't allow us to shut off servers. If we were to shut off a server, we have to wait for everybody on it to hang up the phone, and we don't know if that's going to take 1 hour or 6 hours, so our downtime is slow. Our real-time scaling really comes in political seasons, because a lot of our customers do the campaign dialing, and the calls, there's a lot, that's when we really do it, like in October. We handle a lot of calls, and we have to ramp up a lot of servers for that month leading up to elections and things.
And what kinds of choices do you have to make when you're sizing your infrastructure, the type of droplet or the type of server you're using? What are the considerations there? What choices do you have to make there?
So for the applications, it's mostly we need network bandwidth, and CPU is probably the most important thing. Memory on server isn't important, but CPU and network is. We have a pool of central caching servers, and those require disk and memory and CPU, but the actual servers, the bulk of our servers are just CPU for packet transcoding and things like that.
Okay, so when you need more, when you have more demand, are you choosing to scale up to higher CPUs, or are you adding?
We're scaling out to more droplets.
Okay. Okay. Yvan, if I could go to you, could you tell us a bit more about how your application is architected, and do the components scale independently or not?
Yeah. When you work in a startup and you're designing your software architecture, you've got to ask the question, like, what does success look like for my company? And what kind of problems do I really have to solve for the business model, and what can I get away with, right? And we're not a typical SaaS company. So we've got tons of users, but they interact with the Bevi, and that's an IoT device, basically. The number of users of our backend, that doesn't scale in the same way as the number of Bevis. So there we can get away with basically every couple of months we go in the list of droplet sizes and we pick the next one, and that works for us now. And so that enables us to spend time and development effort and at the things that do matter for our customers, which is the end user experience and better forecasting of what the actual consumable state is.
Okay, excellent. Anshul, could you provide a bit more information about the application itself and the components of it and what scales and what does not?
Sure. So there are so Accern tries to take the whole data science pipeline end to end, and I really like how Yvan described the main offering that DigitalOcean provides. Like you want people to learn, build, and scale. We are kind of trying to do something analogously similar on the data science side. So we gather a lot of data. So there's a massive data ingestion component where we are buying a lot of data. We are scraping tons of websites. So the volume is in hundreds of terabytes of data that we have to kind of keep taking cold storages of. So I think the DigitalOcean product team is well aware of all our issues, history there. And then there's a whole big element, which is the data science, the actual analytics pipeline, and that's where you require. So for the data ingestion, that's something we go very broad and we scale horizontally, because you can just keep putting new pushers, and like you can put a Kafka ingestion system and then put all the data right out there. And in between, where the actual machine learning and NLP happens, that's where our scaling elements are all vertical. So we need to actually get high compute resources so that as soon as you get the articles, they get processed as fast as possible. And at the end, it's just the delivery component, which is not really too extensive, because our data directly gets ingested as an API, so we don't have too much of a web traffic. But so majority of the scaling is at the moment currently needed on the machine learning part. So there we have clients who still want 5 milliseconds of processing, not 40, and they're like, oh, we have that specific as a requirement. So right now there's a lot of effort going on building better systems, optimizing the code base so that it scales better. But yeah, we kind of cover both horizontal and vertical scale. So
if I understand your application, part of it is you're crawling and gathering information. And how many pieces of content do you hit?
So every day we get about 10 to 15 million articles.
Okay.
In our system, and that means the website, including the whole HTML page and everything.
Okay.
And then we process all of it. So over time, it kind of builds up to literally hundreds of terabytes of data. So that's one of the things that very, very soon you'll be requesting, how do we deal with petabyte storage, right? Like, because that's where we are actually going to.
So this is one of my favorite questions I'm going to ask each of you. If you found out tomorrow, or today, you found out tomorrow you're going to have to handle 100 times the amount of websites you have to crawl, or 100 times the amount of transactions you need to process, what would you do?
So right now I can tell you, like, this is we are actually dealing with this problem as we speak, but on a smaller scale. So there is always a catch-up going on. There's this huge effort ongoing with regards to changing the code base, going towards technologies that actually support better scaling, moving a lot of our components to Spark and all the other technologies that are available. But really, like that, it's actually a catch-up. Like every day, if we just plot the amount of new articles that we're getting every day, it's almost increasing exponentially. So when we started in 2014, our volume was about 2.5 million articles a day, and right now we are easily hitting about 10 million articles a day. So I think the engineering team is actually thinking about ways in which we can optimize our code bases, and at the same time launching more and more instances on more droplets. But yeah, like that's I don't really know right now, to be honest.
All right, so Russell, for your business, this is pretty interesting. If all of a sudden none of us were allowed to use email or texting, and everyone had to make phone calls tomorrow, and that meant that your volume would go up by 100 times because we're all making phone calls and actually talking to people. What would you have to do to scale up or scale out?
Well, the first thing we'd do is spawn up 100 times more servers than we have right now. But the biggest concern I would have at that point is going to be the reporting and monitoring of what's actually the content, the quality of that traffic. I mean, it's storing that many records in the database and providing a real-time interface to our clients to see what's happening, so they can monitor their network underneath. Would be one of the biggest challenges, and looking for the right database solution to manage that volume of data and get the reporting they need. If our reports aren't updated within a minute of the calls completing, they generally update real time, but if they're not within a minute or two, we start getting calls from our largest customers saying our real-time monitors that we use to monitor our traffic, and by that I mean they're like, who's calling mobile in Pakistan, and they got 15 vendors, and they're watching the quality of the calls across all those vendors, and they have to know who's working and who's not so that their systems can take vendors out of route and make real-time decisions. So scaling out to handle the calls, I don't think would be a problem. Scaling up a database or a load share database, we use Mongo for most of this. We're actually looking at other technologies now. But scaling that out far enough to handle that load would be my largest concern.
Yeah. Okay. Yvan, anything to add to that scenario?
Yeah, our current application is rather monolithic. I don't know if that's an allowed word, DigitalOcean event. But that doesn't mean that it's not asynchronous. So it's already very asynchronous, and we can even out the load of all the events that come in. So, and we still can grow comfortably there, maybe not times 100. But then I would look at the write part, which is all the events come from all the Bevis, versus the read part. So when service people consult the data, it's mostly reads. So I would split up those two different use cases and work on that.
Thanks. I hear a lot about scaling vertically versus scaling horizontally. With this trend towards immutable infrastructure, the ability to scale horizontally is a lot easier. So I guess I'm wondering, if any of you have a perspective on, are there certain use cases where scaling vertically is the way to scale, or is the trend more towards just scaling horizontally? Is it kind of one or the other, or is it kind of both? And for what use cases? Any of you guys have comments?
I think it depends on the use case. I think our use case is maybe the minority, but growing vertically, scaling vertically still makes sense. But I think no matter what, you've got to pay attention to automating the whole deployment process. And so we deploy a couple of times a week with software updates, and that goes mostly automatic, so that you don't come for surprises in that area. So that's important no matter what, I think.
I've been in telecom for quite a while now and been through the process of doing both. We've spent a lot of time scaling up database servers, and that it gets you somewhere, but you have to come up with alternative solutions. When you have 100 million records a day coming into your database, you have to think of different ways of providing that data. But we have, especially 10 years ago, it was more before the, maybe 15 years ago, it was more scale up. It was, you need faster databases. You need more cache, more RAM, more at the SSD cards that you can get for caching inside the servers. So we went that route, and it only gets you so far, though. You have to come up with a way to scale out and distribute that load. You can't upgrade a forklift server every 6 months if you need it. You need to upgrade, and it's too expensive, and it just is not a scalable way. But sometimes you're forced into it because what your application is currently structured.
Anshul, what do you think?
So I would agree that it totally depends on the use case here. As I said, like part of our application requires very horizontal scaling, but then we also understand that the machine learning components, especially most machine learning algorithms, require a lot of RAM. They require a lot of compute power. And they just cannot be broken down into pieces across different servers. So that's why I think majority of our droplets on DigitalOcean are just high compute droplets. So yeah, for our use case, that particular element, when you're doing heavy machine learning or like heavy data analytics in general, or statistical processing, that's where you'd really need to scale vertically.
Okay, that's great. I want to move on to best practices from a scaling perspective. I think from I'm going to just follow up with just two final questions, I think. On best practices, first, if you were to build your application again, knowing what you know now about scalability, would you change anything? Whoever wants to start is fine.
Sure. I would rely more on, we started the core of our application over 10 years ago, and today I would definitely rely more on more standard, well-known technologies. We're starting to shift most of our infrastructure and the communication in the back to use RabbitMQ as a messaging service. It provides a lot of scalability in the way it works and a lot of the ability to connect your applications. And I would focus more on building microservices for my own internal use. And some APIs and microservices for our customers, but I would definitely use more. There's a lot more standard open source tools that you can deploy today versus rolling your own.
Bevi's problems on the back end, I think I would still do the same thing there. I think there's more opportunity to do better things on the front end, meaning at the internet connected devices.
Okay, Anshul?
So, I mean, Accern, when we started, it was literally coded in a basement and with like very, very little resources available. So if we actually knew the scale of the problem that we would be tackling over time, initially it was just a hobby. It was fun to just do all this machine learning and big data processing. If I had known a little earlier, I would have pivoted to big data technologies much earlier. So that's where a lot of time, there's a dedicated team that is just refactoring a lot of code base that has been written on some legacy technologies and then completely migrating them to big data technologies. So that's what I would have definitely probably put more money in earlier and then pivoted early on.
Okay, well that's great. So one final question for each of you. When you think about your business and your applications that you're building over the next 12 months, where do you think you'll be focusing your resources from a scalability perspective? Is it going to be in software and tooling, implementing new software, new tooling? Is it going to be changing processes, or is it going to be, with people? Any thoughts on over the next 12 months as you scale? Where are you going to focus to get better scale out of your applications?
So I would say for us, right now we are putting a lot of emphasis on monitoring. Because we now have a lot of servers, and then there are we need a lot of reports to be getting generated all the time, so that specific teams would know what is exactly going on. So that's where we are putting a lot of effort on, because it doesn't make sense to, just because you launch a lot more servers, you are just scaling up the team just so to catch up with that number. So we are building more automated processes so that we get alerts when something goes wrong and stuff like that. So that's where I think next 12 months we are going very heavy on figuring out when people are not getting data in certain latency threshold and stuff like that. So.
Okay, great. Russell?
For us, I hope it's adding people, specifically developers. We're growing and we're trying to keep up with our customers' demands, and we're integrating more products into our product, more services into our product, and having additional developers help to focus on key areas of that. And is probably one of our biggest challenges, is meeting those demands quickly and keeping our customers happy and bringing on new customers. So it's really staffing up.
Yvan?
I got the same answer as Russell. It's not so much scaling the technology as scaling the team and hiring the right kinds of people for us.
Yeah. Okay. Well, that's great. I think that's all we have time for today. So I want to thank all of our panelists for participating, and we do have a breakout in a little bit. So thank you very much.
Thank you.